Welcome to everyone. Previous class we have discussed about of that spectroscopy, and we have discussed about of the rotational spectroscopy, and we also have discussed that about of that moment of inertia and center of gravity. So if the two molecules are rotating, and if the two molecules have same mass, then center of gravity will be lies in the middle of the two particles. And if the center of if the two molecules are rotating and they have that different mass, then the center of gravity will lie towards the molecules with heavier mass, because that the condition for center of gravity is that m1 equal to r1 equal to m2 r2. If this is m1 and the distance between center of gravity and that particle is r1, then m1 r1 has to be m2 r2. So if this condition to satisfied, if it has the higher mass, then obviously that m2 and m2 is high, then r2 has to be less, so that it will satisfy that m1 r1 has to be equal to m2 r2, because for center of gravity always this condition has to be satisfied. So we have also discussed that molecules can rotate in variety in different ways. So accordingly we have that different types of molecules. So today we'll discuss about of the different types of molecules we have. So mainly four types of molecules we will get. Four types of molecules. First one we will say that about we can say that is linear molecules. So first we can say about of that linear molecules. So if I say that linear molecules, then what? So linear molecules, if we say that will rotate, it means let's say let's say this is the linear molecules. If you say, if you look at this is the linear molecules, let's say this is the linear molecules. So here let me take the examples. Let's say if we have that CO2 types, so let's say here C, here oxygen, here oxygen. So in the middle carbon is there, here oxygen, here oxygen. So these molecules, this can be rotated in three ways. If you take about of the three dimensions, that's it. If this is the linear molecule in the plane, then we can rotate these molecules means we are studying about of three dimensions. So three way we can rotate. It means that let's say this is x-axis and this is y-axis and this is z-axis. Then we can rotate along x-axis. X-axis means this direction is the x-axis. So if you rotate these molecules, then we will rotate like this. Means if I rotate this pen, then this with this, if this is my axis, so if I rotate this axis, means if I rotate along this axis, then this molecule will rotate like this. So I am rotating the molecules along x-axis because this is x-axis. I am taking this x-axis, this is y-axis, this is z-axis. We can take any like if you take, then we can somebody will take that here. Let's say x-axis, here they take z-axis, then say y-axis. So like that, depend that in which axis you are taking, accordingly the we will rotate the molecule. So we are assuming that this is our x-axis and this is our y-axis and this is our z-axis. Then if I rotate along x-axis, then I can rotate the molecules like this. So if I am rotating the molecules, then that here the two atoms are there. So these two atoms in this particular position, they are not changing its relative positions. So if the relative positions is, while rotating this x-axis along x-axis, this molecule is rotating its own place. Means that relative positions of this, means wherever the atoms were there, on that atom's molecule still is lies if I rotate like this. Means that molecules, the relative position is not changing. So if I say that, if I say x-axis I am rotating, then relative positions, the relative positions of the molecule is not changing. So if the relative position of the molecule not changing, if I rotate like this, if I rotating along x-axis, then the molecules, its positions wherever it was, it is the same place it is like. Means that the amount of, means that now I want to know about of the moment of inertia. So moment of inertia means we have discussed in the previous class, that is somehow related with the mass. That moment of inertia is equal to we have discussed that moment of inertia is equal to mass into r square. This r is that center of distance between the center of gravity and the molecules, and this is the mass. So this moment of inertia is somehow related with the mass. So since the molecules are not changing its relative position, means that I say that I actually while rotating along x-axis, I not applying the much more force because the molecules are not changing its relative positions. So here, so the force required to rotate is almost zero. The force required to rotate the molecule is almost zero because the molecules are not changing its relative positions. Okay, if I rotate along x-axis, this is x-axis. So now let's look about of the y-axis. What about of y-axis? So this is x-axis, then this is the y-axis. This is x-axis, then this is the y-axis. If I rotate along the y-axis, then I have to rotate like this. I have to rotate. So if I rotate, then this, it will rotate like this. It means that this is the center of gravity in between. So the center of gravity is lies here. Center of gravity is lies here. This is the center of gravity. So that center of gravity is always fixed. Not that center of gravity, not center of gravity is always fixed. So only that the relative positions of the molecules will change. So along x-axis, both center of gravity is always fixed, and this relative position of the molecules also same because this molecule is not changing. So the force required for me is approximately zero because I am not changing that molecule. So I not, so no, means that the mass is remaining it is own place. Okay, so now next, if I say about of the y-axis, then what happens in the y-axis, that whenever I rotate this molecules along y-axis, then a molecule is rotating like this. It means that this mass is changing, means this relative positions of these two molecules. Let's say one is oxygen, another is oxygen. So this oxygen, this is the one oxygen, this oxygen. So when I rotate along y-axis, this is changing its relative positions. Previously it was here. After rotate I, it will change like this. Means that relative positions of these two molecules is changing. It means their relative positions of two molecule is changing. It means that now that so the force required means I'm actually changing the mass of these two molecules. So I need some force. The force is not equal to 0 because I changing that mass from this position to this position. Because if I rotate like this, so from this position to this position I'm changing. It means that I need some amount of force. So now the force required to rotation of molecule is not 0. It means that IA is not 0 here. IA is almost 0, or we can say that IA is 0. But here that for rotating, since this mass is to rotate this, means I have to rotate this molecule, so relative position is changing. So the moment of inertia is not 0. Moment of inertia means this mass into r square. So I'm rotating the mass, so mass is changing, means mass is not 0 here. So IB is not equal to 0. So this is, let's say, this directions. This is the y-axis. This is IB. Okay, let's discuss about what about the IC. So IC is along z-axis. So z-axis means which is this is the z-axis. This is x-axis. This is y-axis, and this is z-axis. So if along this direction if I rotate, then I will rotate like this. I'm rotating like this, means I rotate like this. Means here also both the mass of this oxygen is changing. It means here also IB is not equal to 0. So along z-axis also the relative position of two molecules is changing. So here also the relative position of two molecules is changing. So IC also not equal to 0. So this is along IC, I can say. This is IC. So if you look, then for both y-axis the relative position of two molecular is changing, and for z-axis also relative position of two molecule is changing. It means that both y-axis, this is along y-axis, this is along z-axis. So both y-axis and z-axis, that IB and IC, the same two molecules are changing. Here also relative position of two molecules is changing. Here also relative positions of two molecules is changing. It means I can say that IB is equal to IC, and this IA, whenever rotating this x-axis, then no molecule is changing. So I can say that this is not equal to IA, and IA equal to 0. So in linear molecules, what we see that whenever in linear molecules, if I rotate along x-axis, then this, so no relative positions of two oxygens are not changing, so IA is 0. And whenever we rotate along y-axis, let's say this is IB if I take, the relative positions of two oxygen is changing, or two molecules is changing. So IB is not equal to 0, but here two molecules are rotating. And at the same time, if I apply along z-axis, then also two molecules are changing. So IA and IB is same because both the case two molecules are rotating. And whenever I ever talk about IA, then no molecules, their relative positions are not changing, so IA is 0. So this type of molecules are polylinear molecules. So you know that only linear molecules, they have IB equal to IC but not equal to IA, and IA equal to 0. So next type molecules we will talk about of the symmetric top. Symmetric top molecules. So symmetric top molecules, if I discuss, then these molecules can be like these types, that this type of molecules can look. Okay, so means three molecules are same, like say if I say any like CH3F. So if I talk CH, H, H and F, and we know that whenever this is the heavier atoms and this is less heavier compared to fluorine, this is less heavier compared to F, it means that center of gravity will lie somehow the heavier atoms, so somehow here it will lie center of gravity. And we know that molecule always rotate along center of gravity, along center of gravity, means that center of gravity lies somewhere here in these positions. So now also I will look that x-axis, this three directions, this is x-axis, this is y-axis, and this is z-axis. So if I take about of that x-axis, then this I have to look here. So if I rotate along x-axis, then towards at the centers I have to rotate. The rotations will be from here I will rotate. So if the x-axis, so if we say that this is x-axis and this is y-axis and this is somehow z-axis, okay, so I have to rotate along this because from center of gravity only molecule rotate. So if I rotate like this, then this one, this one, this one, this four, and even this pipe whole will rotate like this. If I rotate like this, then whole will rotate. It means that I can say along x-axis whole 5 molecules will rotate. All 5 molecules changing its relative positions. Its relative positions. Okay, next we will look, let's say about the y-axis what happened. So whenever I rotate about y-axis, this directions, okay, because this is x-axis, this is x-axis, this is y-axis. So whenever if I rotate along the y-axis, then what I see that here fluorine atom is there, so it is rotate along this directions. But now the my axis is this directions, means this y-axis contain the center of gravity, and this y-axis also contain the fluorine, also contain the carbons. So if I rotate like this, then it will rotate like this. So it means that this fluorine atoms and carbon atoms is not changing its relative positions. only three things are changing its relative positions. So here if I rotate along y-axis, only three hydrogens atoms changing its relative positions, and fluorine, carbon not changing its relative positions. It means that here that IA here, this, let's say if I am rotating along x-axis, this is if I take IA, and if I doing from y-axis, if I see this is IV, and if I look this z-axis as IC, then this for IA means I means we know that I means that mass into this radius. This is the distance between the center of gravity and the molecules. So if that mass is changing means definitely I is changing. So this mass and I is somehow the good relationship, means if mass is changing means I is definitely changing, and this radius is distance between the center of gravity and the molecules. So I directly say that if mass is changing, relative position of the molecule is changing, definitely I is changing. So if I say that relative position of the molecule is changing, it means I saying that I is changing, that moment of inertia is changing. So all five molecules are changing its relative positions, means I is changing. So along x-axis I say that IA, so IA is changing. So it is have IA, it has some IA, and y-axis three hydrogen atoms are changing and Fn are not changing, so it has IV. And let's talk about of the z-axis. So along z-axis means I have to rotate these directions, So if you see that z-axis also, but if I rotate like this, z-axis means this directions, and means I pass this axis through center of gravity, because along center of gravity molecule is rotating. So this is center of gravity, because this is a fluorine heavier atom, so center of gravity lies towards a heavier atom, because carbon is less heavier than fluorine. So since this is center of gravity, so x-axis is like this, y-axis is like this, and z-axis is like this. I mentioned this here. Okay, so if I rotate along the z-axis, then if I rotate, then whole molecules are rotating. So for z-axis also, what you see that all five molecules are rotating. Molecules are rotating. This is IC. So you see that IA also whole five molecules are rotating, and IC also whole five molecules are rotating. It means I can say that IB equal to IC and not equal to IA. I can say that IA equal to IC, but here the three hydrogen atoms are rotating, here 5, here also 5 are rotating, means these are same, and this is not same, because here only 3 hydrogen rotating. So I am applying less force, means I am applying the IV is less, because here only 3 molecules are rotating along y-axis. Okay, so I am applying that less force to rotate the molecules. So it means IV is same, because IA is somehow related with mass into radius. So this mass, so if high mass, then I have to apply much more force. If less mass means if I rotate like this, so since I have to rotate only 3 hydrogen atoms, I have to miss less mass, so I have to apply less force. So if I say force means, you say that IA I am applying. So for y-axis I am applying high IA value is high, Here also IC value is high because 5 I have rotated. Here also 5 I have rotated. For this case, only 3 atoms are changing, so means 3 hydrogen only I have rotated, then IB is less. So I can say that IA equal to IC, because here also 5, here also 5. So IA equal to IC, and this is not equal to IB, because here I am applying less force. Also I can say, or IA equal to IC, and this is greater than IB. Okay. So we can say that symmetric top molecules and now in another case, if I talk about of like molecules, this type of molecules, let's say these molecules, like they are in the planar. Okay, these molecules, let's say if I talk about this, let's say these molecules, and let's say about these molecules. You can look these molecules. Okay, so here let's say about of BCl3 like molecules. Let's say BCl3 type molecules or BS3 type molecules. So what you say here, let's say here is B, and let's say here is Cl and Cl, and here Cl. So since these all are same, so center of gravity lies somehow in fluorine, in bromine atom itself. Okay, so let's say this type of atoms, this type of atom. Okay, so here I can say this type of atoms. Okay, so here also if you see that with the t-axis we will look, this is axis, this is y-axis, and this is z-axis. So now if I look along x-axis, then since this molecule is in the plane, so I have to look x-axis this directions. So if I apply this direction x-axis, then I have to rotate only these two molecules, one each, here and here, this one. So if I rotate, this is x-axis. Okay, this is x-axis. So I am applying this here. Then how many molecules will rotate? You see that this and this only rotate if I applying this here. So x-axis, two molecules are changing its relative positions. And one molecule is fixed because this is lie in x-axis. So one is not changing. And now if I look about of that y-axis, so now let's look about of the y-axis. This is x-axis. Okay, this is x-axis. Now if I look about of that y-axis, let's say this is the y-axis. You see that this is the y-axis. I'm applying here y-axis. So can I show this? Yes, this is the y-axis. This is the y-axis. Here say this is the one atom, here one atom, here one atom. This is the x-axis along. Now y-axis, this d-axis. So for y-axis, if I rotate, then three molecules is changing its relative positions. Okay, so y-axis, three atoms are changing. Here not two here, sorry, here two molecules is changing for x-axis. Two molecules are changing and two molecules is remain fixed. One is this chlorine, another is this boron atoms. So here two is fixed, not one. Two is not changing, two are not changing. And whenever in three, if I apply along y-axis, then what, the one is not changing, but that is boron, and these threes are changing. These threes are changing. So three atoms are changing and only one atom is not changing. So it has some axis along, let's say IA, and this is, let's say, IB. And let's talk about of that Z axis. So if I talk about of Z axis, so Z axis is somehow this directions. If I say these two atoms, here also one atom is light, here one atom, this is one atom, this is one atom, this atom. Z axis is along this direction. If I apply Z axis, then these two will change, and this boron atoms which is in the middle will not change. It means two atoms are changing and two atoms are fixed. Fixed are boron and one hydrogen. Here also two atoms fixed, boron and hydrogen, and two are changing, that is two hydrogens. Here also two hydrogens are changing. Here three are changing, means three hydrogens, and one is fixed, that is boron is fixed. So you see that z-axis and x-axis, that here also two hydrogen fixed, and two hydrogen changing, here also two hydrogen changing, and two are fixed, that is boron and hydrogen, here also boron and hydrogen. It means that if z-axis, let's say IC, and this is IA, then I can say that IA equal to IC and not equal to IB. So I can say, if I applying that this is IA and this is IB and this is IC, then what I see that IA equal to IC and not equal to IB. Okay, because here that what, the three atoms are changing and what, one atom is not changing. It means that here I need more force, because here three atoms are changing, here two. So this IB is also, I can say that IA equal to IB, and this is greater than, sorry, I can say IA equal to IC and IB is greater than both of this. So what we found that for BSL3 and BS3 type of molecules, what we found that IA equal to IC and that is less than IB. And this type of molecules like CH3F molecules, what we found that IA equal to IC and that is greater than IB. This is the case 1 we found, and case 2 what we found, IA equal to IC and that is less than IB. So these are the two cases we found. Okay, so these symmetric tops are, under symmetric tops we found that two types. One is where IA equal to IC and that is greater than IB. Another is IA equal to IC and that are less than IB. So we can say that symmetric tops divided into two types. So one case, what, IA equal to IC and that are greater than IB, greater than IB, another is IA equal to IC and that are less than IB. Okay, so this where that IA equal to IC and that is greater than IB, this type we call solid molecules, and where these two are less than this, that's we call oblate molecules. Okay, and if you notice that this type of molecules are like CH3F, NH3, so these are about of the point group of C and B. So wherever the C and B point groups are all lies in prolet types, and that N should be greater or equal to 3, not less than 3. Okay, and here that we see that this type of molecule like BS3 and BCl3, so what we found that this type of molecules are generally DNH type molecules. Okay, DNH type point groups, and that here also that N greater or equal to 3. And exceptional is there. Exceptional is that alene systems, that its N is equal to 2 but still it is prolet. Okay, and these are the symmetric top molecules. So you can say that here that how many rotational constant. So another point you have to remember that number of rotational constant equal to total types of moment of inertia. So here we see that one is this type is one type of moment of inertia, and this is another type of moment of inertia. So you will get here two types of moment of inertia, two types of rotational constant. So you can say that two rotational constant you will get, and here also two rotational constant. And what about for linear molecules? So for linear molecules, what you see that here also this is only one type of rotational constant because another is 0. So here we will got in symmetric tops, in linear molecules, one rotational constant. One rotational constant. Okay. Now we will discuss about of that next type of molecules, that is spherical top molecules. So what are the spherical top molecules? So we have discussed that about of that NH3 that is CNB type molecules, where these are same and above one was different, this one was different. Now if I take these also same molecules, so if I take that one also the same molecules, let's say same molecules, so we can say so let's say all molecules are same, this and this is also same molecules, let's say like CH4 type molecules, H4. Means all are like this is also black, this is also black, this is also black, this is also black, means all are same type of molecules. Then that type of molecules fall under spherical top molecules, like it have all OH point groups and TD point groups, like that point groups fall in spherical top molecules. Okay, so where no lone pair and all atoms are same. So here the thing is that here that uh, dipole moment is zero because if we say that mm, for this type of molecules, since all atoms are same, so dipole moments will cancel with each other. So dipole moment is zero. If dipole moment is zero, then we know that microwave dipole moment is zero, then these molecules are inactive. For microwave active, dipole moment should not be zero. So since dipole moment is zero, microwave inactive. So this type of molecules we will not show that spectra. Okay. So like CH4 molecules, SF6 type molecules, okay, which are fully symmetric, that falls on the OH and tetrahedral point groups. Okay. So in these molecules, if we rotate along x-axis, means that here C H H H and H. Since all atoms are same, so that center of mass is lies in carbon itself. This is the center of mass, center of gravity, sorry. So previously here was F, that's why center of gravity lies somewhere here. But now all hydrogens are same, so center of gravity lies here. So if I rotate along x-axis and y-z-axis, if I rotate along x-axis, then that all four will rotate. Like say all will rotate. Similarly, if I rotate along that y-axis, then I have to rotate along these directions. Then also that all atoms will rotate, except that carbon atoms. All power atoms will rotate along x-axis or along y-axis and z-axis because these all are same. So that dipole moment will zero, and this point group tetrahedral and octahedral point groups are fall in this spherical top molecules. And now that last type molecules, that is asymmetric top. Asymmetric top molecules are like, we can say that CND or DTH molecules where N is less than or equal to 2. So this type of molecules like C2B, CS, D2H, these point groups, like you can say that water, these molecules will lie in asymmetric top molecules. So here that IA not equal to IB not equal to IC, and this spherical top molecules, what that IA equal to IB equal to IC for symmetric top molecules. Okay, and for asymmetric top molecules or not equal. Okay, so today up to this, thank you.